Hi, my name's Tyler Turner, and this is my Lab 2 video for Physics 2. Let's start with the introduction. The purpose of the lab can be categorized by three different purposes. So the first was to determine how distance interacts with the strength of magnetic fields. The second was that of learning the difference between the on-axis and off-axis field magnitudes. And the third is to compare the calculated via our experiment and simulated via glow script magnetic field values. So we had two key principles that were integral in understanding the lab's mechanics. The first was that of the bar magnetic field formula, which is right there on the right on the top, and the one below it is the Biot-Savart law, which is the same general principle but correlates it more with current and how that conducts the final value. So the experiment had a lot of tiny steps, but they can be categorized into four main ideas. The first was that of gathering the materials, which included the bar magnet, tape measurer, the magnetometer, scotch tape, and access to Excel and GlowScript for the later part of the lab. The second main thing was to position the foam with tape, take the measurements with the magnetometer, follow those steps, take each measurement 3 times to take averages so that we could plug this into Excel and find our values. The third step was that of the data analysis and calculations through GlowScript and Excel, like I just said. And the fourth step was that of comparing the simulated model with our actual results and answering the questions. So this is a general overview of the lab findings that I did through this experiment. So the first was the value of n, which I calculated to be 3.145 a times m cubed. The estimated regression model through Excel was calculated to be y equals 3.19x minus 14.18. The simulated value for b was determined to be that vector right where it says simulated b, and the calculated b value was right below it, which is obviously a slight difference, but generally very close together numbers. And I also found that as distance increases, the magnitude of the magnetic field weakens, which will be key in answering one of the questions that we needed to answer later in the lab. So before moving forward, it's important to discuss any possible sources of error in calculations, as well as some assumptions that were included before starting the lab. So the first error is that of human error, which could obviously be things like perhaps I didn't hold the measurement devices 100% correctly when performing the experiments. And there's also the error potentially of magnetic influences, such as different things perhaps involving the magnetism, it being skewed a different way, or perhaps the charge being changed of the magnet, perhaps when handling it with human hands. Those are all possibilities that could have slightly changed the values. And a key assumption, of course, is that of the simulation assumes the lack of interference. For instance, the GlowScript code that we generated obviously doesn't take into account, accidents, mistakes, slight errors like that. And so an assumption we have with that is that it operates in a perfect world. We were given 4 different possibilities in this lab, and we had to answer which of these statements describes what you observed, select the all that apply. And so what I discovered when performing this lab was that the farther that the magnets were, the farther the distance was, the lesser magnitude that there actually was. And so this brings us to circle answer number 4, which is as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases, which tells us that overall distance does indeed play a role, and that the closer the distance, the greater the magnitude. There were 2 hypothetical situations that we were given. The first is on top, and it basically says, what if we had laid out our meter stick at some intermediate angle with respect to Earth's magnetic field, and how would the results have changed? So if we had actually done this instead, the results would have been skewed in the direction of true north, and there would have been more error as a result. This wouldn't have given us very useful findings and would have made things more complicated. So it would ultimately have not really led to anything productive. The second what if is that what if we redid the experiment, but instead of using one magnet, we used 2 stuck together, and how would our measurements differ? The direction wouldn't change, but we can obviously see that this would actually increase the magnitude by about, well, 2, because there are 2 magnets instead of 1, and so this would increase the magnitude and not change the direction. So those are the answers to those hypothetical questions, and with that, that is the end of Lab 2. Thank you for watching. Have a nice day.